Hello friends, welcome back to Department of Physics, Shivaji Science College, Nagpur. Today we shall have discussion on how the data recorded in the laboratory can be picked up to fit into a line or a curve. This is in the literature, this is referred as interpolation and extrapolation also. So, first of all, we shall deal with the simple equation of line, how a best fit line is found out, and what should be the ideal way. And we shall learn the way that Gauss has given to us. Gauss's method is a very famous method which offers us a very perfect equation for the data. If the data is consistent, then the fitting things are very fine. If the data is not consistent, then the statistical parameters may show you effect of that. But the method given by uh, Gauss is a wonderful method. Let us go through it. Let us suppose that we are interested in finding a best fit line for the given data that we have collected in the laboratory. And here we are talking about the interpolation and extrapolation processes. Interpolation means you are trying to find out some value between two observations. Actually, you are taking observation. For example, we shall be discussing some observations recorded at the interval of 10 degrees centigrades. And if you want intermediate value for the kind of calibration curve between 30 degree and 40 degree, you have one data at 30 degree, another at 40 degree, you can calculate at 47. That is called interpolation. And extrapolation is after the final data and before final data. Now that region is a very tricky and risky region to predict. But if you like to predict by a straight line, then you can extrapolate. If you like to predict it by a polynomial, then the mathematical know-how, we are going to discuss how that is going to help us. Let us suppose that we have this data which is collected from the laboratory observations, and the observations are taken starting from room temperature, say 30 degree, and the independent variable is the temperature, and dependent variable is say thermo EMF of some thermocouple that we often use in the physics laboratory. Let us suppose that at 30 degrees centigrade it offers 0.2 millivolt or kind of any unit you like. And at the interval of 10 degree we have recorded the data. I have plotted the data at the same time to show you that it's not perfect data which is falling on a line, and never it will be a perfect data falling on a straight line. So we observe different points which are kind of dislocated from the straight line behavior. Actually, the calibration curve should be a straight line in this region we are talking about. The zigzag nature you can just see in the screen. And if you plot a line which passes through 1, 2, 3, 4, 5 points, maximum points we have covered out of the total 8 points. But is it a correct way? No, it's not a correct way. Is this a correct way? Another 4 points are lying on the line, and the 4 points are lying above the line. So this is also not a correct way. Then what is the correct way? So here I have plotted a line whose equation I have shown you, and this is quite correct in the sense that some data points are on the line, some are above the line, and some are below the line. The deviations you can study, you can sum out the deviations would be zero. So this is a better way. We shall now be interested in how to find equation of a line which is best fit for the given data point. This is called as linear least square fitting. Sometimes the data points are not linear, so you may not try a straight line equation for that. Rather, you should try some polynomial equation which best fits into the line. And if you can do that, then you can predict things more accurately. And here you can see that interpolation is okay game, but extrapolation, the things are behaving in a totally different way. However, if you are very clear with this polynomial fitting, then you can try that extrapolation, but the extrapolation is always with a caution whether the things you are talking about in form of a polynomial are okay or not. Interpolation is not a very serious issue in this case. Now, as I said, if you fit this same data in the form of a line, then extrapolation goes this way, whereas interpolation is not having much difference, but extrapolation points are differing in a big way. Here you can see if we plot a polynomial, then the interpolation points are going in a different way. Uh, Nowadays, we have good computers, desktops, and laptops which can serve this mathematical processing very easily. In the early era, it was not so. Visualization, simulation, everything is available nowadays. In Excel sheet, you can find these equations. But here, my concern at this point of time is that what mathematics works behind the Excel sheet also to find a trend line. We can fit our data into a variety of equations. I have developed a C language program also, which I'm going to show you as a hands-on experience, wherein you can fit your data points into equation of line. Some exponential function you can express, like you can express in a form of a logarithmic function. Power function also you can use, and polynomial. So here I am going to discuss the first and the last case. However, the C language program which I have prepared is for all five kind of equations. Then after doing interpolation, extrapolation from the equation that we are now going to understand, you can very well fit that and then later on see how perfect your equation is. So standard deviation we are going to understand. After finding out the equation, we can visualize the data points along with the line generated or a curve generated by the equation. And in most of the university courses, C language programming is mentioned. So here I shall give you the know-how to write a program. Obviously, I'm not going to show you the statements I have written in the C language program that is reserved. However, I'll show you the flowchart, how you can accept the data, what processing you have to do, what mathematics is playing role, that we shall be discussing. Now, least square fitting can be done in form of a polynomial, and the first line fitting is a linear polynomial which was first developed by Gauss. Gauss is supposed to be one of the greatest scientists, greatest mathematician the world has ever produced. He has worked on many aspects which are mesmerizing, and today we are going to understand his own method which he has developed in the era he was alive. You can understand 1777 and 1855 AD was the era he has been on this planet. The least square fitting method we want to do in form of equation of line y equal to mx plus c is the equation of the line which we are trying to fit into the given data, and what we want to know is slope of the line and y-intercept of the line. So first of all, we shall do summation for all data points, and the summation rolls from I equal to 0 to I equal to m, and then rearrange the equation as summation yi minus mxi minus c square. So this summation is assigned to a quantity, say capital S, and this is pertaining to the least square fitting. And for the square fitting, we want to minimize the errors. So S should be as small as possible. If there is no variation in S in finding slope, that is M, and if there is no variation in S in finding C, obviously that S function will have minima for those conditions, and del S by del M equal to 0 and del S by del C equal to 0. These are the two equations which are emerging out, and these two equations later on, which are in the form of xi's and yi's, which are known quantities, and m and c are the two quantities which are to be found. So these two equations can be solved for two unknowns which we are calling slope of the line and y-intercept. Now basically this equation S is differentiated with respect to m. So function to the power 2. So 2 times function to the power 2 minus 1, that is 1, into derivative of the function. So this time we are differentiating with respect to m, and the derivative will be twice the summation uh, to the power 1 into derivative with respect to m will offer us minus n. So here you can consider one minus sign also along with, so this is that derivative. Then you can differentiate. Now friends, the derivative of the function s with respect to m, here this should have been minus xi, 2 into function raised to 2 minus 1, that is 1, into derivative of the function with respect to m will be minus xi. Here there should be a minus sign, but that is not going to bother us much because it will be sucked when it will be compared with 0. Second derivative we are finding of s with respect to c, treating all other things constant. So n, I mean 2 into function to the power 2 minus 1, that is 1, into derivative of the entire function with respect to c. So here derivative of c will be 1. As it is minus c, the derivative will be minus 1. So these are the two equations, and now here we are interested in finding, I mean comparing these two equations with 0, because we are putting a condition that the least square parameter capital S, when differentiated with respect to m and c, it should vanish. So it should have minima, and that minima will offer us the best fit. So let us try to substitute the quantities at their respective places. And here, if we rearrange these equations comparing with 0, see this 2 will be, you can divide the equation by 2, and you can open this bracket xi yi minus m times xi square minus c into xi equal to 0. So you can rearrange that equation, and you can look at the equation as m, which is not depending on summation, so out of the sign. summation which rolls from 0 to capital N, where capital N is the number of data points you are collecting in the laboratory and considering them to plot in the equation, or plot, considering them to find equation of line. So summation xi square plus c times summation xi to the power 1, I have purposefully written this is equal to summation xi yi. The second equation yields m times summation xi to the power 1 plus c into summation xi to the power 0. So anything raised to 0 is 1, but this summation is going to give us something which is pertaining to total number of observations, capital N. This is equal to summation yi xi to the power 0. So this rearrangement I have done here so that our equations are proper, they are normal equations, and once they are normal, you can solve them for finding the constants. Now, by this tricky rearrangement, we have finally ms2. Here we are substituting s2 as summation x to the power 2. Then summation xi to the power 1, you can write s1. So these summations I am writing as s2, s1, and this mixed product xi, yi is yi into xi to the power k. So that is tk. So here xi to the power 1, that will give us t1. So this is a tricky thing we are doing here to write normal equations, and the second equation will be ms1 plus c s0 t0. These are now two equations to be solved for m and c simultaneously. And we in calculus we have Cramer's rule, where we can write delta for the equation. So for writing delta, you are considering S2, S1, S1, 0. So this is the first determinant delta. Delta for finding delta M, you have to replace this first pair by T1 and T0. So instead of S2, S1, we have T1, T0, S1, S0 are as it is. And for writing delta C, we have to replace this S1 and S0 by T1 and T0. So this is delta C. This is a standard thing which is taught in the 11th standard in India. So M can be found by delta M upon delta, and C is equal to delta C upon delta. So here you can look at M as a ratio of two matrices, sorry, determinants. So M is equal to this determinant upon this determinant, and finally you can look at that value as M equal to, you can solve this determinant uh, T1S0 minus T0S1 and so on. So this is how we have worked out M and C in form of S and T, which are generated from the data points. Now friends, we have to fit it into a polynomial, which is y is equal to mx plus c. Now instead of y, we can write a linear polynomial p of x. So if we resubstitute the S and T in form of summations, you can just pick up a piece of paper and pencil and work out that these are the equations where the quantity n has arrived from summation xi to the power 0. So that will sum out to be the total number of observations and the general equations as I have explained you in the earlier slide. So you can check the correctness of the equations by finding deviation, and you can find out mean deviation, and the mean deviation should be 0 for best fit, and standard deviation will depend how the data, how accurate your data is. Now this is limited to the fitting of a line and your correctness of data. So standard deviation has nothing to do at this point of time with the theory we are talking about fitting. If some data is fitting into a hyperbola or a parabola kind of thing, then it's not fitting well into the line, then your standard deviation will appear sizable in that case. Now, I have again brought those observations we have recorded in the laboratory, and here we have data points which are plotted where temperature is along x-axis and thermo EMF probably in millivolts is on y-axis. So this is the program all fit to .exe which is developed in the C language, and here I am picking up the data, how many data points the observer wants to key in, that is to be inputted at the first place, and we have this data which are 8 data points, so we have to key in 8 number of data points, and one by one the scanf command has collected data in form of an array in C programming, and they are assigned x1, y1, x2, y2 in that sequence. Xi's and yi's are collected and the data is keyed in. So here, eighth data point, 100 degrees centigrade, 45.5 millivolt is keyed in. Now the program is in position to, find equation of any form. At the first glance, we shall try to find out the equation of the line which is y equal to mx plus c. And here the choice to be entered is 1 for that. So by doing so, it will once again show you the data that whether it is correct or not, you can go through. And from the program, we have found m equal to 0.656667 and C equal to 19 minus 19.3333. So here we have equation of line like this. Here you can see deviation of the first point is minus, so below the line. Second point is also below the line. Third point is above the line, and so on. So these are the deviations, and sum of deviation is 0. Average deviation will obviously 0, and standard deviation is 1.9. So now we can plot a line. These small dots are plot through line, which is y equal to mx plus c. We have just now found out. So here you can do interpolation the way you like. So for any precise value of your independent variable, that is temperature, you can find out corresponding thermal EMF. So here interpolation is very precisely done where the deviations are minimum, rather zero. So this can be a continuous line because we have an equation and we can generate as many number of points as we like, that makes to fit into a perfect line. So friends, we have found out the line, and now same data which we have already entered can be used for another kind of uh, equation, that is a polynomial. In this case I shall enter the choice 5, which was for polynomial. So it is once again showing you the data, and 8 data points we can to the maximum we can write a polynomial of order 8 to fit this data, but that doesn't make very great sense. We shall try to find out a polynomial of second order, third order. So a0 plus a1 xk plus a2 xk to the power 2 plus a3 xk to the power 3. So here our objective is to find a0, a1, a2 and a3. So here we are using same Cramer's formula, which I'll explain you later on, to find out this. And you can see that uh, the best fit polynomial of third degree is like this, and sum of deviations is quite small, mean deviation is yet small, and standard deviation is further small. So if you try to fit the data into polynomial of higher and higher order, then your standard deviation will go on becoming small, but is not feasible. And if a law is good, it should not have a very high ordered polynomial. Like, so here you can see how the given data points are fitted into a line. A fine dotted line indicates the line equation y equal to mx plus c, and this is a polynomial of quite a high order, which is almost passing nearby every data point. And you can visually see the data points which are isolated 8 points in the graph. Now friends, we shall go through the nonlinear least square fitting method quickly, and the things are very simple. We are just going to extend our equation, number of equations more, and here we have, if we consider a polynomial of degree 3, order 3, then we have to work out 4 constants, a0, a1, a2 and a3, and for that you have you need 4 equations. So in general, if the order of the polynomial is m, you produce m plus 1 equations, and you need to find m plus 1 constants, I mean coefficients. So basically the method goes in a same sense that to find out uh, a0, you need to differentiate the polynomial with respect to a0, then with respect to a1 and so on. So in general, ak I am considering, if you find derivative of s with respect to ak, your equation appears like this, and from that you have a number of equations. Here we have m plus 1, so m is ruling from 0 to that value, and so the number of equations are m plus 1 including 0th equation, and you can simultaneously solve them for those constants. So again, exploring the Cramer's rule, delta can be written like this, and delta L can be written in this fashion: S0, S1, S2, Sm, and here the L element series is this one, and here it is to be replaced by T's in the same fashion, and delta 0 upon delta will give A0, delta 1 upon delta will give you A1 and so on. So in general, delta L upon delta will give you AL. So the third order polynomial looks like this. Here you at least need 4 data points. So because you have to solve 4 equations, you need at least 4 data points, and then you can find out polynomial of order 3 in that case. So here, while working out C program, you need to work out these summations, uh, xi to the power 0, xi to the power 1 and so on. Here in C language, arrays are written with a square bracket. So here I have used square bracket, and this n is rolling from 1 to I. So here x to the power 1, x to the power 2, 3, 4, 5 and 6 is required, then y to the power 1, y to the power 1 into xn. So here x to the power 0 is accommodated, x to the power 1, x to the power 2 and x to the power 3. These are the summations which are required to be found out from the given data points. And once you find that, you have a matrix. So this is the first element A11 and this is the last element A44. So this is the entire matrix, and the corresponding y values are shown as B1, B2, B3 and B4, which is summation y into x to the power 0, y into x to the power 1, y into x to the power 2, y into x to the power 3. So once you work out this, you can use Cramer's rule for finding del, del 1, del 2, del 3 and so on. From these del values, you can find out A0, A1, A2 and A3. So once you work out these things, you can calculate y value. Yc represents calculated y value, and the difference between actual experimental and calculated, that we are calling deviation. So your mean deviation formula is like this and standard deviation formula is this way. For writing program, you have to start the program, you have to key in how many data points you want. So I is a suffix that rolls from the first data point to the last data point. So you have to first define how many data points you are using. Then you have to scanf the data, that is in the form of xn and yn, and once your n is satisfied, this loop which is activated to getting the data is completed, then you have to work out the summations that I have listed earlier, which you can look in the form of s and t's. And the moment your s's and t's are worked out, you can use the basic equations to write simultaneous equations and solve them together by Cramer's rule. Then you can evaluate the value of deviation, then average deviation and standard deviation. So you can print out the equation which is generated out of your program, and you can print out the average deviation, deviation of all points, average deviation and standard deviation. So this is how things roll. Another example for polynomial fitting I have considered. So you can key in 5 data points to plot a polynomial of third order. Minimum 4 data points are required to find out 4 constants. So 5 is also okay. If your number of data points is quite a large, the fitting will be a better one. So here the arbitrarily generated data points are like this. You can write them down on a piece of paper with a pencil, and you can consider them for plotting for your experience. And here our program yields value of A0, A1, A2 and A3, so that the generated polynomial equation looks like y equal to A0 plus A1x plus A2x square plus A3x cubed. So these are the data points which we have started with, and this is a kind of isotherm which most of the material science people find in their various properties, and you can feed them into a polynomial. So this is the polynomial equation found values. So you can see that corresponding to x values which you have experimentally keyed in. For that, your calculation goes like that. And if you want to find interpolation, uh, detailed interpolation that you can do to a very quasi-continuous kind of precise value of x and corresponding y. And here, the sum of deviations is quite a minor. Mean deviation is almost zero, and standard deviation is also quite good, 0.8. So this is how you can go through linear least square fitting and non-linear least square fitting. The beauty of the program, which is developed in the C, that almost all postgraduate students of physics are undergoing, you can use your laboratory data for that. I shall try to make the executable file generated in C available to students so that they can experience the effect of the program. They can write their own program from the flowchart and the mathematical background that I have given through this. And interpolations is quite okay, but extrapolations is to be done with proper introspection. And the correctness is evident from standard deviation. It all depends on the data, how consistent your data is. I hope students will find this program interesting, and we are planning to come out with such more lectures. So subscribe our channel so that the latest new things that we are placing that you can observe. Thank you so much.